The following content is created by DrAvitech. Your support and donation will help me continue to offer high-quality educational resources for free. To make a donation, send an email to 6drcyril@gmail.com or comment donations below. Welcome, ladies and gentlemen. So, my name is DrAvitech, and in this video, we're going to be solving this very problem. And let us see how we can obtain this Fourier series. Sometimes, because I have found Fourier series of so many functions, I can actually tell what a function is going to look like by looking at what the function is defined by. Currently, I know what this function will look like, so sometimes I want to graph it. So let us graph this function. Why there are some functions that I will see, I won't even bother about graphing them. I will just go straight to the point to find the Fourier series. But right now, let us graph this function. Who knows? We might not really need to stress ourselves about all the coefficients. There are times where we just solve only a few. So this one right here, let us graph this function. Yep, I'm going to stand like this to make my diagram much more straight. So this is minus pi, this is 0, and then this is pi. So that's my x. Oh, this is t, not x this time around. So this is minus pi to pi. So that is it. Good. Now, we have this as our interval. So we know that f of t, or you could say y is equal t plus pi. And let's put in our minus pi. So this will be y equal, our t is minus pi, right? Good. So minus pi plus pi, so y is equal to 0. Now what does this tell us? This tells us that when t, am I blocking? Okay. When t is minus pi, because what I did here was to put t as minus pi. Because within this interval, t is from minus pi to 0. So when t was minus pi, y was 0. So it means it's going to be on this part. That's the mean it's going to be on that very part. It's going to be on that very part. Next, y is equal t plus pi. Let's put in our 0 here. So this is y equals 0 plus pi. So y is equal to 0. So what does this tell me? This tells me that when t is equal to 0, that my y is equal to 0. Sorry. Hold on. 0 plus pi is pi. Oh my, I think I'm on drugs. That was a joke. I don't do drugs. So let's continue. So this is y equal to pi. So let me put my pi somewhere here. Good. That's not looking as if it's pi. Okay, let me put it here. Okay, so that's what we have. So this means that the line is going to be from this to this. That's just the meaning. So I've been able to put t plus pi. I've been able to graph t plus pi. So this is my t plus pi. Now the next one is t minus pi. So y is equal to t minus pi. So y would then become, for t minus pi is from 0 to pi. So let me put t as 0 first. So this is 0 minus pi. So y is equal to minus pi. So right now, when t was 0, on the y-axis, you look for minus pi. So this is the y-axis. Let me put minus pi here. So it's somewhere here. Then the next one, t was equal to pi. So we know that y is equal to t. We know that y is equal t minus pi. So y is now, when t is now pi. So this is pi minus pi. So y is now equal to 0. So at t equal to pi, this is pi, y was 0, so it's going to be on this very axis, that very part. So you don't have to connect them together. And if you look at this carefully, if you look at this beautifully, what would you notice? This is an odd graph. Yes, it's an odd graph. It is, because I've already explained even an odd functions before. So when you have the same kind of function on two opposite sides, so one is on the second quadrant, one is on the first quadrant, the function will be an odd function. So there's a video on even and odd functions. Go and watch that very video so you know what odd function look like graphically. So this is an odd function. And if this is an odd function, the only thing you need to find is b sub n. That's the beautiful thing about all of this. The only thing you need to find is b sub n. So right now, b sub n is 1 over pi integral from minus pi to pi of f of x sine nx dx. That's what b sub n is. But another beautiful thing is, since you've been able to determine that this is an odd function, and the function itself has a split at the middle. So hear me out. Let me say this again. The interval is symmetric. Apart from it being symmetric, there's a split at the middle. So here's the thing. If you can know what this part is, why not just double it to get this other side? So that's the whole idea. So instead, I'm going to say this is 2 over pi integral from 0 to pi of f of x sine nx dx. So that's the whole idea. That's why this is beautiful. That is why this is actually very fine, to know when it's even or odd. So as you can see, we have reduced our limit of integration. Instead of minus pi to pi, we're now doing 0 to pi, making things much more easier for us. And this will be 2 over pi. Then, integral from 0 to pi. Now, what is f of x? From 0 to pi, f of x was t minus pi. So this will be t minus pi sine nx dx. So this is 2 over pi. Now let's integrate. But to integrate, I would like to use integration by parts. So there's a shorter way for that. So this will be t minus pi. That will be t minus pi. Now write your t minus pi. Then differentiate the t minus pi. So when you differentiate t, you will get... Sorry, this is supposed to be... the function is not with respect to x. It's with respect to t. So let me put the t. Yeah, sine nt dt. Oh no, this is t. Where is it again? So this is t and this is t. Okay. So let us differentiate this with respect to t. So differentiate with respect to t. This t will give you 1 when you differentiate it, because it's with respect to t. So when you differentiate t, you will get 1. When you differentiate the minus pi, you will get 0, because pi is a constant. Pi is a constant, so you get 0. So next we're going to do is, after this 1, when you're done getting your derivative of this as 1, you need to differentiate it again. So if you differentiate 1, you will get 0. But 0 is nonsense, so you cannot throw it away. Now, this is t minus pi. Your sine nt will be integrated. Most persons call this DI method. DI method, differentiate and integrate. So they call it DI, differentiate and integrate. So I'm done differentiating, let me integrate. So this is sine nt. Let's integrate sine nt. First of all, the integral of sine will give us minus cosine of nt. Then we need to divide by the derivative of nt. So if we differentiate nt with respect to t, you will get n. Now this answer that I've got, so you need to integrate it again. So this is times minus, there's a minus here, so write minus. Integrate cos, you will get sine nt, then over, there's been an n before. So if you should differentiate this nt, you will get n. So n times n is n squared. Now the correct sign for this is plus minus. And then you put your limit 0 to pi. Take note, this is the same thing as doing your normal integration by parts. It's still the same thing as doing your normal integration by parts. Still the same thing. Okay, so our b sub n will become 2 over pi. Now let's simplify this whole bracket. It's looking kind of messy. So let's make it simplified. So bring this minus to this place. So this will be minus bracket c minus pi cosine of nt over n. Minus times minus is plus sine nt all over n squared. And this is from 0 to pi. All right. Now the good thing about this is, sine nt within this interval will give us 0. Because when you put pi here, sine n pi is 0. Sine 0 is still 0. So this guy is gone. Sine n pi is a special value. Sine n pi will give us 0. Sine 0 is still 0. So it's basically 0. So this is the only thing that is remaining. This is the only thing that is remaining. Now, this only thing that is remaining, I want to bring out the minus. I want to bring out the n. Remember that it's anywhere I see t that I'll be putting this interval. Since it's only the place I see t that I'll be putting the interval, it means I need to only keep the things that have t. This any does not have t. Let me bring it out. The minus does not have t. Let me bring it out also. So the minus comes out to give us minus 2 over, the n comes outside to become n pi. Then what will be left to become t minus pi cos nt from 0 to pi. So now let's put in our limits, because I'm trying my best to make this very, very simplified. This is minus 2 over n pi, and then this is t. So anywhere I see t, I'll be calling it pi. So instead of writing t, I'll call it pi. So this is pi minus pi cos nt. So this is the upper limit. Minus, now anywhere I see t, I'll call it 0. So this will be 0 minus pi cos n. Oh, this is also t. I should have put my pi here. Cos n times 0, which is just cos 0. That's just cos 0. All right. Now, pi minus pi is 0. Pi minus pi is 0. 0 times cos nt is still 0. So everything here will just be 0. So we have minus 2 over n pi. Everything here will just be 0. And then minus 0 minus pi is what? 0 minus pi is minus pi. So minus pi times this minus will give us plus pi. Plus pi times cos 0 is just pi. Let me say it again. Cos 0 has a special value. Cos 0 is 1. Cos 0 is equal to 1. So 1 times anything is what? That same thing. So that is why here, whatever you get here, this is minus pi. So minus pi times this minus will give us plus pi. That's why. Sorry. So pi will take care of pi. So this will then become minus 2 over n. So that's b sub n. That's b sub n. So right now, let us find the Fourier series of this function. Let's find the Fourier series. So b sub n is the sum from n equal to, f of x is the sum from n equal to 1 to infinity of b sub n sine nx. So that's what it is. So right now, this will be the sum from n equal to 1 to infinity. Our b sub n is minus 2 over n. This is minus 2 over n sine nx. Now, the constant term here is minus 2. Because my summation is with respect to n. The summation is with respect to n. So the minus 2 does not have n. So I bring it out. So this is minus 2. The sum from n equal to 1 to infinity of, what will now be left is 1 over n sine nx. Now please take note that if they say leave your answer in terms of n, this will be your answer in terms of n. But if you are asked to write it to the, let me say, fourth harmonic, so n equal to 4. So this will be minus 2, open up a bracket, sine x plus 1 over 2 sine 2x plus 1 over 3 sine 3x plus 1 over 4 sine 4x. All right. So what I did was, anywhere I see n, I'll be putting 1. So this is 1 over 1 sine 1x, which is the same as sine x. Next, when n is equal to 2, this will be 1 over 2 sine 2x. Next, when n is equal to 3, 1 over 3 sine 3x. When n is equal to 4, 1 over 4 sine 4x. Just like that. And this will be the answer to that very equation. So it's actually something easy to solve. It is not difficult. So with this, I am done with solving this very problem. Remember to start this very video from the beginning. Remember, if you have not watched other videos on Fourier series, check out my playlist. And with this, I'll end this very video. I'll see you in the next one. Bye.